Well, hi guys. Today, again, another episode in our series of learning to be a C# developer. I decided to tackle something. Just squeezing this in as an extra episode. I decided to tackle the question of, well, firstly, self-documenting code. Okay, self-documenting code refers to the fact that just by looking at the code, all right, you can understand the code. You don't need necessarily documentation included in it in the form of comments from the programmer that wrote that piece of code explaining to you what they did. All right, so there's nothing wrong with doing that. In some cases, it's very necessary that the programmer puts a comment in, like on top of a function to explain something or so forth. But you don't want to go overboard with it and just have all this green code, we call it, all over the place. Green because if you comment something out, it turns green. All right, like you can see there, it's gone green. All right, so we don't want too much green stuff in there. We need it at times, but we don't want too much of it. Okay, so now by just looking at this code, all right, in the few seconds that you've had to look at it, okay, you might know what it's doing, but possibly not. Okay. You will notice quite a few things in there, especially if you are a seasoned C# developer. You'll notice there's quite a few little problems in here, things that shouldn't be done that way. And what I can say is, this is our front end, okay, so this is the, again, a console app. So it's calling a class called friends, on which it's doing certain things, all right. Very simple. That's all the code is here. Okay, and yes, and it should execute and do something for us. Okay, so now the first thing we can do is always to make sure that our code runs is to build it. Okay, and see that it builds. All right. So if we build it, we're doing a sorry, I pressed the wrong key there. What is it? Control B. All right. So we're doing a build. And it says down here to us, build succeeded. All right, so that means there's nothing wrong in our code. Everything is good. We didn't forget a semicolon somewhere. Everything is good code. All right, so that means we can run it, and we should get some kind of output to the screen, because like it says here, we are doing a write line to the screen. So if we run it, hey, great, it should work and print out something for us. And oh heck, it fell over. Okay, why did it fall over? I mean, it compiled fine, okay, and I mean, a lot of people consider that as being the gold standard, but it compiled, okay, but that doesn't fix, the compiler can't fix logical errors and so forth. Now, what happened in this case, okay, is we are using something called a tuple, all right, and your Mad Max super senior developer probably knows what tuples are and uses them a lot just to get on everyone's nerves, maybe. So what our problem is if we look at where we declared this array, all right, up top here, okay, it's declared as a type array list. Okay, now some of you older programmers out there would remember that back in pre-2005, we would use array lists to create lists of items, of objects and so forth as an alternative to a normal array. And then after that, in 2005, in Visual Studio 2005, we got generic lists, which was excellent. If I do remember correctly, Mono on Linux got it just before it came out in 2005, but that's just for interest sake. So what I'm saying is, so we've got this array list, okay, and what we're doing is we adding a tuple to it. Now, what a tuple is basically, so yeah, we're adding to the array. All right, a tuple is a C#, well, it exists in many languages, but it's a C# object that you can use instead of, for instance, creating a class or saying, you just want to very quickly bunch a couple of variables together. Okay, so the way you do it is just with a open brace and a close brace, and just list your variables inside that. Now the problem is, okay, that object is actually a string. Okay, although he didn't know that at compile time. All right, so if we come look here, for instance, at add here we've said object is a string. Okay, and I'm jumping a little bit, maybe it's a little bit difficult to keep up, but okay, so let me start better here though. So if we go through this whole the start process, okay, it creates an instance of friends, all right, and in the constructor of friends it calls a method called addAll. We don't know what addAll is, but it's calling addAll, all right. So here's the method called addAll. So what it's clearly doing is it's creating an array list, and it's adding items to the array list. It's adding tuples to the array list. Okay, so we've got John, we've got 22 and a 0. So we don't know what that means. Okay, there's nowhere where you can like hover over something that tells you what those things are. So the only way to really figure it out is there's no documentation that tells us. All right, so the only thing we can do is we got to come back and look where, where was it used, etc. Where was it declared? We've got to look through all our code, and here we find something. All right, we've got a name, an age, and something called very nice. Okay, we don't know what that is. So the name is an object. Okay, age is an int, and very nice is an int. So okay, we're sort of understanding what's going on now. Okay. We could say we should replace this tuple with a class, or at least a struct or something, but we'll stick to classes. Okay, but to fix this very specific problem we got at this moment now, because it's an object, all right, the moment we went and we added this as a string, all right, now all over the place this tuple must now be changed to a string. All right, so in other words, we ran into a runtime problem, okay, because that means we only ran into the problem when the program was running. Okay, that is called a runtime problem versus a compile time problem. Now, what you ultimately want is to find all your compile time problems and fix them before they are sent out to your client. Because once it's up and running, okay, and your system crashes, like it just did now, okay, that doesn't look very good for you. All right. So what we've gone and done is we've went and changed them all to strings now. All right. And so let's see what happens. Okay. And so it returns the word Samantha to us. That's nice. Okay. So it's working. The program is working. We fixed a runtime error, which shouldn't have existed in the first place. But because we used object, all right, in a tuple, you should not use objects, okay? You've got to have a very specific reason why you use an object. So I would say there's already one problem with this bit of code that I'm showing you, okay? Because it's not self-documenting. We had to go and look around to figure out what is this in this tuple? What does it actually do? All right. And then, like for instance, if we come and look here and it says, well, addAll, okay, so it comes down here to addAll. So it's got this list, this array list, all right, which we shouldn't be using anymore. It's there for backward compatibility, but some of the older guys might remember it from years ago and still like using it. Unless you have a reason for putting, there's a reason why an array list exists, and that means that you can put different objects in an array. But we want all the objects to be the same, okay? So we actually want to use a generic list, but okay, we'll get to that just now. So if we're just looking here again, so we've created this array list, okay? So it's a list, okay? An array list to which is called friends, to which we can add these tuples. All right. we don't like that. We want that rather to be an object, okay? Because we don't know what these tuple things are, all right? So what we should go and do, okay, is go and create for us. So in friends we are adding. So clearly this is a friend, all right? So we can go and create a new class, and we'll call it friend. And that's that, all right? Now, if we go back and we remember, okay, our tuple had, so it's got name, age, and very nice, all right? So nothing here tells us what this very nice means, okay? Age, we assume obviously is the age of the person, but that could be some other age. We don't know. There's nothing that tells us what it is, all right? So you could, for instance, have a comment here saying that this is the person's, age, as in age in years. And name, it could be name anything, but we know that it's the friend's name, all right? We figured it out. By just looking at this, we're sort of trying to figure it out. So if we go back to friend, all right? So we've got three things that should replace this tuple. We've got name, age, and very nice, all right? So we create our class, all right, and we're going to create three properties, okay? Now we know that by looking at the code, that first object had to be a string, okay, and we clearly want it to be a person's name, all right? So friend should then have a person's name or a friend's name. But the thing is, you don't have to say friend name inside of class friend. We already know we're in class friend. So all you need to do is say name, or like let's say first name, for instance, in this particular case. That might be better. But let's say your first name, all right? And that is of type string, not object, string, okay? And we say get and set on that. Copy this. All right, and then we've got an age, all right? By looking at the code, we figure out that this is the person's age in years, all right? So that is age in years, all right? Oops, age in years, all right? And it said it's an int, all right? Remember, if we go look at that tuple, okay, it tells us it's an int, all right? Now an int, okay, means that this person, okay, so that's a signed in. This person can be, millions of years old. All right, that's just not possible. Okay, so one better way of doing it, instead of making an int, okay, is making it a byte. All right. Yes, you could actually create another class that contains purely ages and verifies as ages are correct. Like let's say you allow a maximum age of 120, 150 maybe, all right? But so in this case now, for instance, so we say age in years is a byte, okay? We could in the set make sure that value that they are setting the age to is not bigger than 150, okay? That might be a good solution. All right, so let's do that, okay? So what we're going to do is we're going to create a private field. It is a byte, and it is our age in years. Okay, we'll just give it a start. Okay, age in years. Then at this point here, all right, we just say, okay, do that. Okay, so get. Okay, so we say return underscore age in years. All right, and remember I did cover how to write these properties in previous episodes, the shortcut way, and then doing it the way I'm doing it now, so we can do validations and so forth. All right, then so let's just put that over there. Then we've also got the, like I say, set, so it's set and open and close. All right, so here when we set the value of age in years, okay, byte itself cannot contain a negative number, okay? So you can't send a -1 in. You can't have an age of -1, all right? The age is, well, can, let's say we don't allow 0, all right? You can't be 0 years old. Well, you could be a baby, you're 0 point something. But, okay, so we'll allow zeros. But a maximum age of 150 years, for instance. So what we can do is we say, if, okay, the value of the property that's being sent in is smaller than or equal to 150, all right, then set our age in years, okay, to value. So if they sent in 23, age in years will be 23. Okay, so now, all right, so we've got our, okay, now, but if it's not, okay, less than or equal to 150, all right, then we should return some kind of notification or whatever the case may be. Okay, I'm going to just do a little shortcut way here. All right, I'm going to actually just throw an exception. All right, we can maybe cover exception handling one day as well. So all right, so I'm just going to throw a new general exception. It's just you could throw an application exception. Oops. All right, so that we know that it was not thrown by the .NET framework itself, but by us as the developer. But you can also create your own exceptions. Okay, okay, and then we go tell them, throw new application because it's a class. Throw new application exception and say age must be less than or equal to 150 years. All right, so if the person makes a mistake, okay, our program is going to crash at this point because we're throwing an exception and we're not handling it at any point, which you should be. All right, I'll explain that to you just now, but yeah. Okay, then we've got at the bottom here, so first name already declared, so the last one was this thing, which is very nice. Okay, now we've got no idea what very nice is. All right, what there's no documentation here. What is very nice? And it's an int, so it's definitely a number, okay, that can be, you know, millions is big. All right, and it's called very nice. What on earth would very nice be? Let's see if we can find some clues somewhere. So I mean, like, here's a get where he's actually looking at let's see, item 3 is in the tuple, so that's this one. All right, so that's item 3, so he's referring to this one, so that is very nice. So what he's doing is he's doing a get, and in the tuple, the last object, item 3, if that is equal to 1, he's returning that entire tuple. Okay, so in other words, if this tuple, okay, has this is very nice value equal to 1, he's returning that tuple. All right, so okay, now remember we're trying to get away from this tuple. All right, so this very nice is probably that he likes this person. It's a nice person. Okay, but just for interest's sake, now I'll show you, this is where the problem comes in. All right, if you don't use the correct data type. Okay, so very nice is checking for 1. So you're probably either 0 or a 1. You're either very nice or you're not very nice. Okay, and you'll notice here that when we ran it, we only got an answer of Samantha. Okay, sorry, over here. Where are we? Yeah, we only got the answer of Samantha because Samantha is the only one that's very nice equals 1. Yeah, we got Marcus. He's very nice as 11. Okay, now either that's a mistake and it should be just a 1. So we got noughts and ones, very nice or not very nice, or that is actually what they intended. 11 is a valid value, all right, which means something, but there's nothing here to tell us what it is. So at this point, we have to go and approach someone, find out who wrote this code, you know, speak to someone that knows what's going on here, and that person can say to us, oh, no, that's just a mistake. That should just be 1, all right. So if we rerun it now, it'll say Samantha and Marcus are very nice. So, you know, we're fixing up this code, yeah? So if we go to our class, friend, okay? So we understand that this very nice, okay? You also notice that the original coder coded it like that with a lower very nice. Okay, we use an upper very nice, okay, because it's a property, okay, and it can only have one of two values, so it's not an integer, it's a boolean. All right, so call it a bool. All right, you could have said an integer, but you know that's not really self-documenting. Now we understand by looking at the fact that it says it's a boolean, that self-documented the fact that very nice is either a true or false. No one had to, let's say for instance it was an int, okay, let's say we made it an int, but it may only be 0 or 1. Then you're going to have to put in a comment here, okay, and say must be 0 or 1. As a programmer, you're going to have to put in that comment. And then this person is going to have to do, that's trying to fix up the code, is going to have to do a test here as well, that if it's an integer and it can only be a 0 to 1, he's going to have to do a test as well. The value that's coming in, is it only a 0 to 1? If it's an 11, for instance, it should throw an error. But now, because we've changed it to a boolean, all right, let's go back to boolean. Because we've changed it to a boolean, just by looking at the code, I immediately know it can only have two values, true or false. And very nice probably means that you know you like the person or something, okay, good friend or whatever the case would be. You could maybe find out more information about that. But so if we look at this little class that we wrote here now, all right, so we've got 3 properties, okay. 2 of the properties are declared in the shortcut way, all right, just immediately saying get and set, all right, with the correct data types. Okay, not object and int. All right, so we know that first name must be a string, and we know that first or that name is the person's first name because the variable name tells us. So it's self-documenting. All right, so we know that this property refers to a person's first name and it's a string. So we don't have to write anywhere that, oh, by the way, this field or this property refers to a person's first name. You just look at it and see. Very nice also, we can just look and see. Very nice, you like this person, it's either true or false, bam, we know immediately what it is, okay. Age in years goes a little bit further, all right. So we want to do some validation on that and make sure that they don't send us a value of greater than 150 years, okay, over here. So, and return an error if they do, all right. So that's great. So we've written our class now. So we no longer need that tuple, okay. Tuples do have their place, okay, but not nearly as often as people seem to use them. They're just for very quick little things that, you know, you don't feel like writing a full class. But in this case, I think the tuple is being used so often that actually converting it to a real class makes far more sense, and it's going to make the code far more readable. So in other words, from this point on, wherever we see our tuple, okay, we don't need the tuple anymore, we use our friend. Okay, so let's say for instance, we get to this point now, we're adding a new friend to our list, okay, our array list, okay. So instead of adding a tuple, all right, what we can do is we can go and create a new friend, okay. So we say new friend, all right, takes no parameters, but there's a shortcut way of setting all its properties, all right, and it's going to be the first name equals, well, here the original code just said name, okay, what name, all right, so that should be first name, all right, and we shouldn't be using an object. We know it's a string, we figured that out already, so we make it a string. Now first name, yeah, requires it to be a string, so first name equals first name, okay, so the property first name on friends equals the parameter first name that we're sending in, okay, and then the same would apply to, so it's comma, and then age in years, all right, equals, we could just say age, okay, but that should also be age in years, so that we know what that age is referring to, okay, age in years. Now remember, we said it's not a int, okay, it's a byte, all right, because we're trying to show an intent. Okay, so it's not bigger than 255. When we do set it, also we do a check that it's not bigger than 150. All right. And then the last one, int very nice. Okay, we know that that is a Boolean. All right, and if we come in here now and we say comma, the last option is very nice, equals, and we say very nice. Okay, so what we've done is this add method, okay, now just called add as well. So now we have to put a comment here and say add a new friend to the list of friends, or whatever the case may be. Okay, you could still do that, all right, but you don't have to. Okay, it depends, you know, per project. You can decide how much commenting you want and so forth. But in this case, we basically know what this means. We've got friends. Okay, we're in the class friends, and we're saying add. All right. So no, we know we're adding a friend. Okay, but are we adding friends or are we adding friend? Okay. Now, because we're passing in only the properties of a particular friend, that probably refers to add friend, not add friends. We could have passed in, for instance, a class here, friend, up top here. Okay, so the only property or parameter coming in is a friend. But all right, so we know we're adding a friend. So let's say add friend. Okay, we could say actually add new friend. All right, and then we add that friend to the list. Okay, now in real programming, you should actually check that that friend doesn't already exist in this list. Okay, but it's okay, we're going to allow duplicates, all right, in this example. But in your real code, you should make sure that you're not adding a duplicate. Okay, so we've now fixed our constructor. It takes a couple of parameters of the correct name and data type, all right. And then we create a class of friend, and we set its properties to those parameters we sent through. So we're still sitting with the array being an array list, okay? But that's fine for now, okay? So, but now it doesn't, because we added an array list can contain any object. So we're not adding a tuple anymore. We're now adding a friend object to it. So everywhere else where we're referring to that array, okay, we can't refer to the tuple anymore because it doesn't contain the tuple, it contains a friend. All right, some of you older guys will know exactly that's why the generic array list exists. But okay, so in other words, we don't need this cast here. Okay, we can get rid of where are we that, okay, and that. Okay, all right, dot, and that is, sorry, what am I doing here? Sorry, this, okay, if array x, you see, now, it doesn't know, because array is just an object, okay? Array is just a list of objects, okay? It could be tuples, it could be friends, it could be ones, it could be falses, it can be whatever. So you actually have to say what is it. So you have to cast it, okay, to a friend, all right, and then take that whole thing and wrap it up, all right, and then you can click on it and it says, because now it knows, oh, okay, so in the array list, this object that you're referring to is actually a friend, okay. Now, we don't want that either, okay? We want a list that only contains friends. We don't want, like, why do we have to keep casting this thing? That's what a generic list does for us, all right? So let's say for now we call it array, okay? So when we come up here, where we declared it, okay, we don't declare it as an array list, all right? We declare it as a generic list, okay? So it's, we'll call it, list. Okay, the reason why we have list in here is because of the fact that system.collections.generic is included at top here as a using. All right, it's lying in that namespace. So we want to create a list, okay, and it's got to contain friends. So we put in our data type, which is friend. All right, and then over here, obviously, we have to make sure that when we do the constructor, we do it for that same type. So we've changed the array list now to a list, a generic list. Okay, so that's also self-documenting. It's saying to us, when we look at this code, it's saying we want a list here. It's a generic list. It may only contain the data type friend. So not like an array list that can contain anything. It's now a list that can only contain friends. Okay. Now the other thing is we've got array here. All right. We're going to come back and look at that in a moment. But all right. So we get to here and we say, okay, so we've got our array, which is a generic list, which we're indexing as well with this X. Okay. So if I just say dot here now, okay, he immediately knows. All right. He knows what object it is because that list can only contain that object. So the object we are indexing with X, all right, we can say if very nice here equals 1. But remember, it's not an integer anymore. It is now a Boolean. So if it is equal to true, all right, then go ahead and add to an array list, all right, our friend. Now you can do that, all right. So we're forcing that you can only add friends to an array list that contains friends, to a generic list that contains friends. But the array list here, okay, you can still add anything you want to it. We don't want an array list anywhere in our code, okay? It's bad. You don't want that unless you just want a list that can contain anything. If that is your intent, then an array list is your answer, all right? But for what we're doing, it's got to be the same data type. So instead of putting in checks every time before you add to an array list, is the object you're adding a friend or not, okay, of a data type friend, we can just create a generic list all over the place, all right, and make it of type list friend, okay. Come on, and make it of type list friends, sorry. All right, you can say new array. Now, yeah. You know, it would be better to say, for instance, to make it a little bit more readable, okay, new friend list, and in fact not new friend list, but let's say found friend list, new found friend list. Okay, it's getting a bit long, but you get my idea. New found friend list. So we found our friend in a list. Okay, and this is a new list. In fact, we don't have to say that because there is only one list in here. Okay, so it's just found friend list. All right, so found friend list is going to contain our friend object. All right, and when we return it, okay, now we have a problem here. Of course, well, first the new array doesn't exist anymore. We renamed it to found friend list. So if I change that to found friend list, it's still going to complain because the return value of our get method is still an array list. But remember, we've changed everything to a generic list of type, which contains types of friend. All right. So now we fix the get as well. All right. Now, the get doesn't tell us much. So we have to, again, put some documentation in here and say that gets a list of all our best friends. All right, so we've documented that code. When somebody comes and looks at this code, they can see, okay, what are we getting? Okay, look up here, and it says, I'll get a list of all our best friends. Alternatively, all right, you can get rid of that. Okay, that documentation code there, and just say on your get, rename it properly, not just to say get, but get best friend, or in this case it's actually get nice friends. Okay, nice friends. Okay, so but then again, you know, if somebody is a friend, they will all be nice, else they're not friends. But okay, so get nice friends. All right, so that's starting to look much better now. All right, so our array here though, okay, we've said it's an array of a generic list of friend, and we're just calling it array. Now just by looking at the code, like array.add, what is array? Okay, we're adding what? Well, we're adding a friend to it. So I suppose that is an array of friends, I assume. Okay, you see, the thing is now though, as you can see, I'm spending time trying to figure out, because things weren't properly named, Okay, what is this? All right. Well, the thing is, it is my friends list. Okay. So it's my friends list. Okay. All my friends list actually, but it already says friends as the class name. So we assume, well, if it says friends list, that's all your friends list. Friends list. Okay. Or you can just say friends. Okay, that's also fine. Okay, I mean that makes sense. It's our friends, but it's not saying that it's a list though. Now, okay, back in the day we used to have something called Hungarian notation, where part of the variable name tells you what type the variable is. So if you say friends list, for instance, that's sort of like it makes people think of Hungarian notation. Well, but it's fine. We are not just saying friends. We're saying this is a friends list. It's far more self-documenting. We know that it's a list of friends. Okay, so now all our arrays must be changed to friends list. So everywhere where we found friends list, array, we've got to change it to friends list, because we're no longer using the term array. So we're gonna get some issues here. All right, and there we go, array as well. All right, now just for interest's sake, since we're on this last one, yeah. All right, so this is the constructor, okay, and it's right at the end of the class. All right, and it's expecting still an array list, okay, when you're constructing it. All right, we're not using that array list anymore, remember, we're using our generic list. Okay, so first thing we do is we say, well, list friend. Okay, list friend. Okay, so list friend, and that's friends. We're calling the parameter of type list friend. All right, so our friend list gets a whole lot of friends, okay, through our constructor. But another thing that we must look at is constructors. You know, it doesn't do anything to your code or anything, but it's what they call idiomatic. Okay, it's the way that we do things in a certain language, for instance. And basically all languages, your constructor is normally stuck up top before you get to your other functions and so forth. So after we've declared the fields, all right, and properties, okay, then typically we get to the constructors. All right, so we put our constructor up top there. So that's looking much better at the moment. All right, so we've changed our array list to a generic list. So our intent is quite clear. We don't want just a list of objects, we want a list of friend. All right, so that's the whole thing. We're trying to show intent by using correct data types. Okay, and that also indicates, it explains what we're trying to do, because it's easier to understand what the code is, the variables are named correctly and so forth, and therefore it's self-documenting. Okay, we understand what it's doing. You know, like for instance, our variable names, first name. It's not just name, and then we have to add some documentation somewhere that says that name is actually meaning first name, right? Because the code says it's first name. It's self-documenting. It's telling us it's first name. And self-documenting code is what we're after. Okay, self-documenting code and correct data types. All right, they sort of, you know, self-documenting code covers more than just data types. All right, it covers naming conventions and so forth, which is what we've done. We've changed function names, we've changed variable names, we've changed our array list to a generic list of type friend. You know, we're specifying through data types and names, variable names and so forth, what our intent is and what things actually mean. And we've written no documentation yet. There's no green code anywhere yet. You know, we haven't put in any green code to explain anything on top of a method or anything yet. Now, again, I'm saying it's not a bad thing to do that. That's a good thing to do. But the problem is with having that is sometimes, you know, if you explain what's happening inside of a method, especially a long method, all right, then you've got to explain, something about that method in this class. Now, let's say a year later, a different programmer comes along, another developer comes, and he finds that, either there's a bug in your code, for instance, or the requirements have changed, okay, and they want to, that piece of code of yours must be changed. So he comes and he looks at your code, he reads your comment, and he looks at the code, he says, oh, okay, I can change it like this and this and this, and he's made it, fixed it, and some new stuff, and off he goes. But he never updates the comment. So the next guy that comes along, he reads the comment, and then he looks at the code, and they don't make sense, and he doesn't know which one is right. Okay, is the comment right, the documentation right, okay, or is the actual code right? So if we can get away from this green code, where the commenting is, all right, then all the better. Okay. But at sometimes it is necessary. So, all right. So, like I'm saying, so that looks much better. We've now got our friend class that actually shows correct intent. And then the other thing that we've also done is, like I say, we've replaced that tuple with an actual class. Okay. So we can actually look at this class and know what's going on. Okay. There's some code in it and so forth. It's replaced the tuple, which, a tuple's got its place, but please don't overuse it. It's like using var, okay, in C sharp. I hate it when people use var. There's a good reason for it. Okay, like here I've got an example of where I'm using it here. Okay, the reason is, all right, you have no idea what. Okay, so initially, before I renamed that get to get friends or whatever, it did fr get. Okay, now, fr is the name of a friends class. Okay, so on the friends class there's a method called, or was a method called get. Okay, and it returned a result. Okay, which is what is that result? Okay, the data type doesn't tell us that it is a generic list or an integer or an array or a surname which is a string. It doesn't tell us any of that. Sorry, I just had to take a little break there to let my little puppy out, or my son's puppy, out the room. Okay, where was I? Okay, so I was referring to here. Okay, so we're looking at result. We have no idea what result is. We know it's the result of a method call, so we know this method returns something, and the programmer is one of these new programmers that what's new is always better and greater, etc., which is not always true. And he's used a var, okay, him being me, to just give you an example here. So we have no idea what actually is going on here. Okay, so luckily we've renamed this get. Okay, so let's see what our options are on this fr dot, and where's our get nice friends. Okay, so get nice friends, all right, tells us something already. So that is our generic list that we're returning. Okay, so if I just go to that method, get nice friends, okay, it's returning our generic list friend. Okay, so what we must do is we must come back here, and this var will now work. Okay, where are we? Sorry, yeah, this var will work. Okay, there's no problem, it'll work. Sorry, semicolon missing here. Okay, but if I'm just looking here and say var result equals, okay, get nice friends. Okay, if I hover over get nice friends, I see, oh, it's returning a generic list of friend. Okay, so okay, I understand now what result is. But if I had to take this piece of code, for instance, all right, and mail it to you because you need some help on a piece of code, for instance, or you want to reuse a piece of code I got, and I send you that, and you look at this, you're going to say, like, what is this var? What is this result? Because you don't have get nice friends declared anywhere yet in your code, so you don't know what this data type is. You're going to have to ask me, what is the result? I'm going to say to you then, oh no, that's a generic list of type friend. All right, so now you can get rid of var. Okay, System, what's wrong here now? The namespace nameless. Do I not have, oh, system collections dot generic. Okay, so we need using system dot collections dot generic. All right, so now our our list will work. Okay, so we've added the generic namespace. Okay, so all right, so we know what we're doing. Our result is a list of nice friends. That line is self-documenting. Okay, I don't like the word results so much as the variable here. Okay, what we can do is we can just change it to, for instance, nice friends. All right, that's a little bit more self-documenting. Result is fine. It's a result of a call to a method. We can figure that all out by looking at just this one line of code. The result is fine, and it contains a list of friend. Okay, but nice friends tells you a bit more, which you might want to use nice friends down your code, maybe way down in your code. You just got this thing result. Like, what is result? Well, now we know it's nice friends. You could say list of nice friends or whatever, but it's just nice friends. Okay. Then the other thing is, okay, naming conventions and, so friends, I just called it FR here, all right? Yes, it works, but that's not a good way of doing things, okay? So what is friends? Friends is a class, all right? So we can just, it's not always, it also used to be frowned on naming a variable after exactly the same as its data type. But I mean, in some cases, it's 100% fine. Like in this case, well, friends, and we want to create a variable for the type friends. What is it? Well, it's friends. All right. There's nothing wrong with it. Okay. And then remember in our constructor here, okay, add all. Okay, so add all. All right. We changed our constructor to take the generic list. It's still the add all method is returning an array list. That should be a generic list. Okay, but the other thing that I notice here is that add all, so it's got a small a there. All right, that's not right. Again, okay, documenting code. A lowercase, that is, it's not a variable that we're referring to up here. We're referring to a method. Okay, and the fact that it starts with capital A, it tells me immediately just by looking at it. I can say, oh, that's a method. And okay, and of course the fact that there's those braces behind it tells me that there's a method. But it's still going to complain to us here now because we are using an array list and not our generic list. All right, which is what we should be using. You could argue you could use iList, but that was covered in when we looked at object-oriented programming and polymorphism and so forth. That will allow you to put different objects inside your list, but as long as they inherit from iFriend, then you can put them in that list. So they might be different objects, but as long as they inherit from iFriend, they can be stuck in that list. But that's for you to read up on why do you use generic lists and why iList is so important, and why interfaces are that important. Okay, so static, so it's list, and it is friend. All right, so now it's returning a list of friend. All right, and friends, okay, the one that we're returning at the bottom here is still the array list. It's still the same problem, so we got to change it to our generic list. All right, and of course then we got to do it as well. Okay, open close there. All right, now all these will fall over obviously because they have no idea. Okay, they're trying to pass a tuple, all right, to a method that takes a friend item. Okay, it's not a tuple anymore, it's now a friend object. Okay, so now like I've shown you before, okay, how you can quickly create all that, all right, is you can create it outside here, you can create your friend there, friend as new friend, etc. Or you can just do it all in one row. All right. So what has to be sent through is a new friend. Okay, there's nothing in the constructor. All right, but we do have some properties which we can set. All right, and the first one will be first name equals John, and then we have what was it, age in years. Age in years equals 22, and then this naught, okay, naught and a 1, okay, that naught normally means false and 1 means true. Okay, it's just a sort of a standard that developers have been using over the years. If you don't have, for instance, a boolean, if you're using a byte or something like that, a number, okay, then naught refers to false. All right, if it was a boolean, and we are now using a boolean, so it's false. Okay, so now we can just copy that thing. Okay, 1, 2, 3. So add all our friends here. Okay, and we just do some copy pasting here. So we've got Samantha. Well, that's too long to copy paste. So what is it? Samantha, George, and Marcus. Okay, so and it's 21, 26, 23. So it's 21, 26, and 23. And then Samantha, I do like here. Why is he causing problems on that? False. I thought it was a boolean, but okay, we'll go have a look at that now. It's supposed to be a boolean. Okay, so Samantha was true, and then it is false again, and then Marcus is a true. All right, true. Okay, then let's get rid of all this down here. All right, and let's see what it's complaining about here. With this false here. System boolean represent boolean, invalid initializer, member declare. Oh, sorry, I didn't say very nice. Okay, very nice equals. All right, so this is a shortcut way that you can, without a constructor, just directly set your properties. Okay, which is what you would have done in your constructor in this particular case anyway. You would have sent it to the constructor, and in the constructor you would set your properties to those values. This is a shortcut way of doing exactly that. Okay, so we're keeping our code nice and short here. It's getting a little bit lengthy and it gets a bit busy on the eye. Okay, that's another thing that's very important that you should remember in your programming. Okay, you are supposed to write obviously good, efficient code. All right, that's supposed to be high priority, is efficiency. But of higher priority, okay, for normal code, all right, your day-to-day code, your readability and understandability and things like self-documentation is very, very important. I would say it's almost more important, okay. But when you find you come across a piece of code that requires some form of optimization, all right, because maybe, you know, it's doing something silly that takes up 90% of the time of your program running, and with a little bit of optimization you can drop that 90% down to, you know, 2%, from 90 minutes down to 2 minutes. Okay, so it's better to go for readability, all right, but optimization is still important. All right, so, okay, we've got no problems anywhere else here. So our friend, our X tuple, now a class called friend, has got no problems on it. All right, our friends class, everything has been changed. I got rid of array list and everything, name things better and so forth. Remember, I did say this add new friend. The friend might already exist, so you could put some validation code in there. And then, okay, so it's only in program here that we still have these problems over here. So, well, the first thing here is FR is just because FR doesn't exist anymore. It's friends, all right? So, okay, FR, there's nothing. Okay, then result also doesn't exist anymore. Remember, we changed result to nice friends. All right. And then the problem inside here is it's still expecting us to be using the tuple, all right? but we're not using the tuple, all right? And also it's looking for this very nice, used to be an integer, and it's 1. So in other words, inside here we know that 1 is actually a true. So we know that this piece of code is trying to find item 3. We know was referring to very nice. All right, so we can say we'll put that dot very nice there now, and we get rid of the tuple bit of code here. All right, and so we say dot very nice. Okay, and that's all sorted out. Okay, that should be on a new line. We've got an extra. Okay, so yeah, that should sort that out. All right, now we're on our very last problem, and it's the exact same thing. It's still that tuple that's causing us problems. You see, you know, you could be using the same tuple, all right, for different not the same tuple, okay, the same signature for a tuple, a string int. That might be used at other places in your code for completely different reasons. It's got nothing to do with friends and their age and are they nice or nothing, and will be very confusing to a programmer going through your code and seeing that the same tuple is being used all over. So they really got to sit down and figure out what on earth is going on in your code, and then realize, oh no, this is a different tuple. All right, but so we take care of that now by the fact that we've specified it as being a particular a data type, which is type friend. All right, so, and we want to return first name. All right, and that's that. So now we should get the same result as what we got just now. So it should kick out our friends that we like, so Samantha and Marcus. And let's run that quickly. And there we go, Samantha and Marcus. All right, so we haven't changed the functionality of our program. Okay, it does the same thing, but we did remove a runtime error. Okay, and then we actually just refactored. You call it refactoring. Okay, it's going over the code and you know, refactoring involves things like renaming stuff, changing data types, changing method names, extracting pieces out of methods into sub methods. That's termed refactoring, and you normally do that so that your code is easier to understand, maybe for optimization reasons. Just bettering your code, all right, is refactoring, and that's really it. So what I've shown you is, you know, so some developers don't know, like I said, for instance, about, you know, generic lists and so forth. The generics is an amazing thing. I use it a lot. A lot of people use it a lot. You know, you can get generic classes, generic methods, etc. That are extremely powerful. So we've replaced an array list with a generic list there. We've named things properly, or better. Like I say, this is still a little bit long, these lines here, but it's something. Oops, somehow I clicked there. It makes sense. It works. I would say if I had to refactor this further, I would actually take this direct call of setting the properties, and I'd rather put this into the constructor, okay, inside here, all right, and get rid of this bit here, and then in the constructor here, where's our constructor here? All right, is this the right constructor? It's friend, sorry. All right, create a constructor here, and then send in the first name, the age, and the very nice to that, and do it that way instead of accessing, sorry, not that, all the publics directly, as I did over here. I accessed the properties directly. But all right, so what I'm getting at is, so, you know, naming is very important, and so forth. But data types is also very important. And if there are languages, for instance, in which the type, okay, can be anything. All right. Like in C#, you can use an object, for instance. All right. All things are objects because everything inherits from object. Okay. But the thing is, that's not documenting the code at all. All right. You don't know what you're referring to. It's just an object. Okay, so if you give him a value of like, oh sorry, this is the other thing, like I. Okay, what is I? All right, because it's just an object. Is I an integer? How do you use I? Is it actually a string? What is I? Okay, the letter I. So this is the last thing I actually wanted to show you is, so in this loop here, I said for int x. Okay, now you should actually have, for instance, a name in there like index counter or something like that. All right, and then use that instead of x. All right, but it is okay, like I've described before, that in loops, okay, over the years, programmers have always used I. Okay, so any programmer that really goes over your code that's been around a while, they'll understand. If you use I, they'll know exactly what you mean. They know that I referring to index, instead of writing out the word index, they'll know what you're referring to. But you can have nested loops, and then it's for I and then J and KL and so forth. But it's okay in this case to use I. I is, like you would think, completely non-descriptive, but because it's used in a loop, we know what it means. Just over the years, everyone does it a certain way. It's almost a pattern, you could say. You'll still learn about patterns in your career as well. Very important. Okay, and so we've neatened it up all nicely. So, and just to reiterate, like I say, the thing about specifying your data types, okay, and not like in this case here, like I say, I can say var here, okay. In other words, what actually happens is what the compiler does is he figures out what that var should actually be when he changes your code to MSIL, Microsoft Intermediary Language. All right, he converts it from C# into MSIL, and then once it's executing, it converts it with a just-in-time debugger, they call it, a JIT debugger, and actually makes your noughts and zeros and executes them on the computer. But so what will happen is this is a shortcut way, okay, of if you're basically not saying what the data type is, that list friend. You're not saying that. You're just saying there's a variable, all right? And the compiler will go and he'll look at, now, well, what variable, what type is that actually? So what he goes and does is he looks at your code and he figures it out. Okay, so he sees, well, okay, what is get nice friends? What does that return? Oh, that returns list friend. All right, so again, I clicked on that by accident. Okay, so that returns list friend. And where are we? Are we on the right place now? Yes, okay, so that returns list friend. I hope you can see on your screen there. It's very small there. And so even though the programmer wrote var, when I actually compile this and actually convert it into MSIL, I'm actually going to write list friend. That's what the compiler is going to do. So the compiler actually does it as if you wrote that, but it saves you from writing that. You can just say var. But it's nice, great, you can just call everything var. But the thing is, it makes your code less readable. And this whole video was about self-documentation, code readability, okay, and data types, okay. And now we've specified better what we want to do by indicating what our data type is. So a programmer doesn't have to figure out like var, okay, what is var? Then he has to hover over get friends. But I mean, if this code was not in Visual Studio, I just sent it to you via Notepad, you can't hover over get friends and see that it's a list of friend. So it's better, instead of using vars, rather to say that. Now in some cases, var is okay in my opinion, all right? I'm not saying that this is the truth, but in my opinion. And that is when you're declaring something, all right? So up here, for instance, instead of saying friends, we could have said var yeah, all right? And I personally would think that's fine, because I can see immediately you creating a new friends. Okay, that's what you're doing. That's what var is referring to. So when you're creating a new object, okay, you can use var. But why? I don't really see the point. Okay, so there's another one like that they brought out, dynamic, but that's okay. That's a different discussion. All right, so yeah, I hope that helped you, and showing you the importance of self-documenting code. I have no green code. I've got no comments added to my code anywhere. All right. Now, it's sometimes necessary, like I say. Sometimes it's extremely necessary. But if you don't do that and your code speaks for itself, it's easy to read. Okay. Then it also, like I say, it fixes the problem where a programmer changes the code but forgets to change the comment at some point, the documentation at some point, maybe the documentation in a book or something. Well, okay, that's a different matter. I mean, I once, I actually, I'm a little bit shy in saying this, but back in, I can even tell you the exact year, I think it was 1998, I made a comment to the company director. We were on a semi-friendly basis, and I was a senior dev there, and we were just talking about commenting in code, and that I should comment more. And I said, you know, if you can't read my code as is, you shouldn't be fiddling in my code in the first place. Now, that is a very bombastic thing to say, but if you think about it, all right. If I as a programmer did properly document my code in the naming conventions and all that sort of stuff and made it self-documenting, then that is a very good statement, actually, that if somebody can look at your code and just by looking at it understand what's going on, all right, due to self-documentation, then you don't need any comments. All right, so you should sometimes ask the question when somebody puts comments in their code, why are you putting comments in your code? Okay, that should be taken care of by the code itself through self-documentation. All right, but in other cases, yes, you do sometimes need to document stuff. And all right, there we go. And I think that's enough for now. And I hope you enjoy your day. And get you next time. See you, man. Goodbye.